If your test mixes tables, mapping diagrams, graphs, and equations, this is the video you need. Just a small reminder before we jump in, the domain is all the possible inputs, or x values, that a function can take, and the range is all the outputs, or y values. Now, let's get started. We need to find the domain, range, and whether this is a function. So, let's start on this table on the left. Domain is your x values, so we look to this column. We see 2, 2, 10, 11, and 14. We write domain and range in set notation, which means we only need to write it once, even if it appears twice. For example, this 2, we only need to write it once. And then we write 10, 11, 14. We tend to write these in increasing order, so it's easier to read. Now, let's do the same for range. For range, let's start with this 2, have 5, then we have 7, have 8, 9. Now, is this a function? No, this is not a function. Because for a function, each input can only map to one output. And as you can see here, 2 maps to 5, and 2 also maps to 8. So this is not a function. Now, let's go to our next question. We're looking for the domain and range again. Last time, domain is x value, so we have 1, 2, 3, 4, 5. Write down 1, 4, 5. Increasing order like last time as well. And now let's look for our range. The y value is here. Start with the small 3. We see 3 twice, but we only need to write it once. We have 4 on this side. We write it once. And lastly, we have 6. Now, is this a function? Yes, it is a function, because each of these inputs is only mapped to one output. Even though we have repeated y's, that's okay, as long as we don't have any repeated x's. Now, let's take a look at some mapping diagrams. Our domain is going to be our input, or this left side, and our range is going to be our output, or this right side here. So let's start off with our domain. It's going to be this left side, so 0, 2, 3, and 7. We have 0, 2, 3. We still want to write it in increasing order like last time. And what about our range? We have 3, 6, 10, and 12. We also have the 17 here, but as you can see, there's nothing pointing to the 17. So the 17 is actually not a part of our range. So our range is going to be 3, 6, 10, and 12. And just like last time, we have 2 things pointing to this 3 here. So this 3 is kind of like double, but because we're writing in set notation, we only need to write it once. Lastly, is this a function? No, it's not a function. And the reason why is because the 2 here is mapped to both 3 and 6. So as you can see, we have this repeated input of 2 here. For a function, we can only have 2 mapped to one thing. Now, what about this problem on the right? Let's look for our domain. That's going to be our left side. 2, 4, 8, 10, and 11. Let's write that down. 11. What about our range on the side? We have 2, 6, 7, 10, 12. 6, 7, 12. Lastly, is this a function? Yes, it's a function. As you can see, each input maps directly to one output. 2 is always to 2, 4 to 6, 8 to 7, 10 to 12, and 11 to 10. Now, looking at some graphs, domain is going to be left to right, and range is going to be bottom to top. So let's get started. On this side, we have domain from 0 to 6. As you can see, we're going left to right, our most left point and our most right point. So that's going to be 0 to 6. As you can see, we have 2 closed circles here, which means 0 and 6 are both included in our domain. So we're going to write this in interval notation, which means it's going to be a continuous set of numbers. For example, anything between 0 and 6 is included, right? Like 1 is included, 2 is included, 2.5 is included, and so on. Now, let's take a look at our range. We're going top to bottom. So this would be top to bottom right here. So that would be from 0 to 3. And notice that these both are closed circles as well. So our range is going to be inclusive 0 to 3. Now, is this a function? Yes, it is a function because it passes the vertical line test. The vertical line test is the idea that to prove that only one input has one output, if you can draw any vertical line between the graph and have it hit the graph only once, then it's a function. What about this graph on the left? What's going to be our domain? We're looking left to right. As you can see, it starts here and it goes all the way here. We have this arrow here, which means it goes infinitely to the right. As you can see, we have an open circle here at -2, which means that -2 is not part of our domain. So we're going to make it a parentheses instead of a bracket. Our domain is going to be -2 all the way to positive infinity. And for infinity, we also use this parentheses here and not a bracket. Now, what about our range? Going up to down. So here our range goes from here. As you can see, our most bottom point is going to be at 0, and our most top point is going to be at 2 here. Because it's an open circle, 0 is not included in our domain, but this 2 here is a closed circle, so it is. Our range is going to be 0 to positive 2. Now, is this a function? Yes, it is a function. Because this also passes the vertical line test. You can see all of these hit the graph exactly one time. Because of that, it is a function. Now, let's take a look at some equations. Our first one is going to be y equals the square root of 2x plus 8. We have to think about whether there's any restrictions between the domain and range. In this case, there is, because we have an even square root here, which means this 2x plus 8 needs to be non-negative, because anything in a square root needs to be greater than or equal to 0. So now, let's solve for that. 2x plus 8 is greater than or equal to 0. So 2x is greater than or equal to -8. We divide both sides by 2, and we get that x is greater than or equal to -4. Other than that, there's no other restrictions, so our domain is going to be -4 to infinity. And it's going to be a bracket because there's an equal to sign here, which means that x can equal -4. And what about the range? What y values can it hold? Well, if you think about it, this can range anything, domain can be anything from -4 to infinity. So the smallest this is going to be is when it's going to be -4, which is 2 times -4 plus 8, which is 0, which means the smallest that y can be is going to be 0. And as domain or x gets really big, y also gets really big. So it can get to infinity. Our range is going to be 0 to infinity. Lastly, is this a function? Yes, it is a function because all of the x's will give a different value for y. Each input will have exactly one output. Now, let's take a look at this one. We have y equals 5 divided by 3x plus 9. Let's start with domain first. Are there any restrictions on the x? Yes, there are. We have 3x plus 9 in the bottom. And for a fraction, we can't divide anything by 0. So we know that 3x plus 9 cannot equal 0. Which means 3x cannot equal -9. Divide both sides by 3. And x cannot equal -3. Your domain is anything but -3. Your domain goes from -infinity to -3. We make sure to use a parentheses here because -3 is not included. We go from -3 to positive infinity. Now, what about the range? Is there anything that the range cannot be? Yes. Actually, the range can't be 0. And the reason why is because to get y to be 0, 5 needs to be 0, because 0 divided by any number is 0. But because there's a 5 up here, it can't be 0. But you might be thinking, is there a mathematical way to come about this? And yes, there is. We'll do it right now. So, we're solving for y here, but instead, let's try solving this entire expression for x. So we can multiply this out by doing cross multiplication and doing y times 3x plus 9 equals 5. Multiplying this out, we get 3xy plus 9y equals 5. Now, let's solve for x here. Let's move 9y to the other side. We get 3xy equals 5 minus 9y. Divide both sides by 3y because we want to isolate this x. And we get x equals 5 minus 9y over 3y. And as you can see here, now we have things in terms of y. And as you can see, we can't divide by 0 on the bottom like last time. So 3y cannot be equal to 0. So y cannot be equal to 0. As a result, our range is going to be anything from negative infinity to 0, not including 0, and 0 to positive. Our domain is everything but negative 3, and our range is everything but 0. Now, is this a function? Yes, it is a function. Because any x you put in, you will get a unique y value. We've arrived at our final challenge question. My question to you is, do all 4 of these representations have the same domain and range? Why or why not? Pause and write down the domain and range for each of these down. Now, let's get started. So I'm going to write D to represent domain and R to represent range just for spacing. So D here is going to be what? Are there any restrictions on what domain can be? What x value can be? No, there's not. There's no square root, there's no fraction, so domain can be negative infinity to infinity, all real numbers. What about range? There's also no restriction on range here. It can also just be infinity to infinity, all real numbers. Now what about this one right here? As you can see, the points here are actually on this y equals 2x minus 1 line. 2 times 3 minus 1 is 5, 3 times 6 minus 1 is 11, and so on. But if you can see, our domain here is actually different. Our domain here is actually these distinct points, 0, 2, 3, and 6. They're only the points that are given to us, not this entire line. And our range are going to be the points that are given to us as well. Negative 1, 3, 5, and 11. What about this mapping diagram on the right? It's similar to this one. It's just the same thing shown in a mapping diagram. In this case, our points are also going to be discrete. The only elements in our domain are what's shown here, 0, 2, 3, and 6. And for our range, negative 1, 3, 5, and 11. And then what about finally this graph on the right here? As you can see, it goes from 0 to 6. So what does that mean our domain is? Our domain is going to be 0 inclusive to 6 inclusive because of these closed circles right here. How this differs from this one is that every single point between 0 and 6 is part of our domain. It's continuous, not discrete like these points. What about our range? Same thing, right? Going from top to bottom, we have from negative 1 all the way to 11. Our range is going to be negative 1. So, although these are all representations of a part or the whole thing of y equals 2x minus 1, the domain and range do change based on how you present it. For example, when you write it as the full equation, Our domain and range are sometimes bigger because it has all the potential solutions. When we write something in a table or a mapping diagram, our domain and range are only the exact points that are given to us. And when we have a graph, depending on how we draw it, it can also be a little restrictive. For example, for this graph to be true, y equals 2x minus 1, we would have to draw arrows on both sides to show that our domain and range are also infinite. But because we have a line segment, just a part of this graph, our domain and range are only going to be in these continuous intervals. And that's the end of today's video. Thank you so much for watching.